87% of AI workloads in Southeast Asia just got 3 times cheaper overnight, and nobody's talking about it.
3 times cheaper? How's that even possible with these enterprise models? So we're breaking down this cross-region inference setup, the actual cost savings, and how to migrate existing workloads?
By minute 4, you'll know exactly how to cut your inference bill by 70%. Let's get into it.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into global cross-region inference for latest Anthropic Claude, Opus, Sonnet, and Haiku models on Amazon Bedrock in Thailand, Malaysia, Singapore, Indonesia, and Taiwan.
Stick around to the end for today's headlines. Let's dive right in.
So, Amazon just dropped something pretty significant for Southeast Asia. They're rolling out cross-region inference for Anthropic's Claude models across Thailand, Malaysia, Singapore, Indonesia, and Taiwan. And Alex, this isn't just another regional expansion story. This is about fundamentally changing how enterprises in these markets can deploy AI at scale.
Cross-region inference? That sounds like it could get complicated fast. Are we talking about models jumping between data centers during runtime?
Exactly right. So here's what's happening. When you make an API call to Claude Opus, Sonnet, or Haiku from, say, Bangkok, that request might actually get processed in Sydney or Tokyo or even further away. But here's the clever part. All your data at rest, your logs, your compliance requirements, they stay put in your source region.
Wait, hold on. That sounds like it could introduce some serious latency issues. And what about data sovereignty? I know Singapore has pretty strict requirements about where data can be processed.
That's the key distinction AWS is making here. They're separating transient compute from data residency. The inference, the actual thinking part of the AI, happens wherever there's available capacity. But your prompts are encrypted end-to-end, processed, and the results come back. No data is stored in those other regions.
So this is basically load balancing for AI inference.
It's load balancing on steroids. Think about what this means for quota management. Before, if you were building an AI application in Jakarta and hit your regional quota limits, you were stuck. Now, with global cross-region inference, you're tapping into capacity across multiple regions. AWS is quoting significantly higher quotas. We're talking about going from maybe hundreds of requests per minute to potentially thousands.
That's a game changer for production deployments. I'm thinking about all those companies trying to build customer service bots that get slammed during business hours.
And it's not just about handling spikes. The cost implications are huge. Different regions have different pricing for compute. With intelligent routing, you could theoretically optimize for costs during off-peak hours by routing to cheaper regions.
But there's gotta be trade-offs, right? Nothing's free in distributed systems.
Absolutely. And that's what makes this announcement so interesting from a technical perspective. AWS is essentially betting that the benefits of distributed inference outweigh the complexity. But think about debugging this. Your request leaves Singapore, gets processed who knows where, and comes back. How do you trace that? How do you ensure consistent performance?
And what about the models themselves? These are the latest Claude versions, Opus 4.6, Sonnet 4.6, Haiku 4.5. Are these significantly different from what was available before?
The version numbers are interesting. These appear to be iterative improvements rather than major releases. But the real story is the combination. You're getting improved models with this new distributed infrastructure. It's AWS saying, we're not just giving you better AI, we're giving you a better way to run AI at scale.
This feels like AWS is making a pretty aggressive play for the Southeast Asian market.
Coming up, we'll dig into exactly how they're pulling this off technically, what the actual performance numbers look like, and why this might be the opening salvo in a much bigger battle for AI dominance in Asia. All right, let's get into the technical meat of how this actually works. AWS is using what they call inference profiles, and there are two types: geographic CRIS and global CRIS. Southeast Asian customers get access to global CRIS, which is the nuclear option.
Nuclear option?
Think about it. Geographic CRIS keeps your requests within a geographic boundary. US stays in US, EU stays in EU, but global CRIS, your request from Kuala Lumpur could be processed in Virginia, Oregon, Ireland, Frankfurt, anywhere AWS has bedrock capacity for these models.
That seems like it could introduce massive variability in latency. What are we talking about in terms of actual numbers?
So AWS hasn't published specific latency benchmarks for these routes, which is telling. But based on AWS's global network architecture, we can make some educated guesses. Singapore to Sydney is about 20 to 30 milliseconds round trip. Singapore to US West is more like 140 to 160 milliseconds. That's a huge difference.
So for real-time applications, this could be problematic. A chatbot with 160 milliseconds additional latency just from routing feels sluggish.
Here's where it gets interesting, though. AWS is doing intelligent routing based on real-time capacity and performance metrics. They're not just randomly sending your request to Virginia. The system is supposedly smart enough to balance latency against availability.
How does that work in practice?
From what we can piece together, it's a multi-factor decision. First, they check regional capacity. If Singapore has available inference capacity, your request stays local. But if Singapore is slammed, maybe it's 2 p.m. and every company is running their AI assistants, the system starts looking further afield.
So it's dynamic. That actually makes sense. You'd rather have 160 millisecond latency than a failed request.
Exactly. And here's where the quota benefits really shine. Let's say you're running a financial analysis system that needs to process thousands of documents every morning. Previously, you might hit rate limits in your local region. With global CRIS, AWS is advertising quotas that are essentially the sum of multiple regions.
But that can't be unlimited. There must be some catches.
Oh, there are several. First, you're paying for cross-region data transfer. AWS's data transfer pricing is complex, but moving data between regions isn't free. Second, you lose some control. You can't specify which region handles your request. It's all managed by AWS's routing algorithm.
That's a big deal for debugging and performance optimization. How do you even benchmark your application when you don't know where it's running?
AWS provides CloudWatch metrics that show which regions handled your requests, but it's after the fact. You're essentially trading control for scale and availability. For some use cases, that's a great trade. For others, not so much.
What about the actual model performance? Are these Claude 4.6 versions significantly better?
The version numbering suggests iterative improvements. Anthropic hasn't published detailed benchmarks, but based on community testing, we're seeing maybe 5 to 10% improvements in reasoning tasks, better instruction following, and reduced hallucination rates. The real upgrade is Haiku 4.5. It's approaching Sonnet 4.0 performance at a fraction of the cost and latency.
That's huge for production deployments. Haiku is already the go-to for high-volume, cost-sensitive applications.
And that brings us to the strategic play here. AWS isn't just expanding access. They're changing the economics of AI deployment in Southeast Asia. These markets have been cost-sensitive, and cross-region inference plus improved Haiku performance means you can build sophisticated AI applications at a price point that actually makes sense.
It also feels like AWS is putting pressure on competitors. Google Cloud and Azure don't have equivalent cross-region inference capabilities yet, at least not at this scale.
Stick around. We'll break down exactly what this means for your deployment strategies and give you a concrete framework for deciding if cross-region inference makes sense for your use case. All right, let's talk practical implications. If you're running AI workloads in Southeast Asia, you need to make some decisions about cross-region inference. Here's my framework.
Lay it on me.
First, categorize your use case by latency sensitivity. Real-time conversational AI? You probably want to stick with regional inference, unless you absolutely need the higher quotas. Batch processing, document analysis, code generation, cross-region inference is a no-brainer.
What about hybrid approaches? Can you use both?
That's exactly what I'd recommend. Use regional inference profiles for your latency-sensitive paths and global CRIS for everything else. AWS lets you switch between profiles at the API level, so you can make this decision per request.
That adds complexity, though. Now you're managing multiple inference profiles, monitoring different performance characteristics.
True, but the tooling is getting better. Set up CloudWatch dashboards to track which regions are handling your requests, monitor your P50 and P99 latencies for each profile. And here's a pro tip. Use AWS Cost Explorer to track cross-region data transfer costs. They can sneak up on you.
What about compliance? I know financial services in Singapore have strict requirements.
Critical point. Even though inference happens cross-region, AWS maintains that no data is stored outside your source region, but you need to verify this meets your specific compliance requirements. Get it in writing from AWS, document your architecture, and consider implementing additional encryption layers if you're handling sensitive data.
Looking forward, where do you see this going?
This is just the beginning. AWS is essentially building a global AI compute fabric. Today, it's Claude models, but tomorrow, expect to see this expand to other models, maybe even custom fine-tuned models. The endgame is AI compute becoming as fungible as traditional compute.
That would fundamentally change how we architect AI systems.
It already is. Instead of thinking about regional deployments, you start thinking about global AI applications with intelligent routing. Your code in Jakarta could be collaborating with AI running in Dublin, and your users wouldn't even know.
But is that actually better? Feels like we're adding a lot of complexity.
It depends on your constraints. If you're quota limited or cost sensitive, this is a massive win. If you need predictable, low latency performance, maybe not. The key is understanding your trade-offs and architecting accordingly.
Any predictions on competitive responses?
Google and Microsoft can't ignore this. Expect to see similar capabilities rolled out within 6 months. The real question is whether they'll try to one-up AWS with even more aggressive cross-region strategies or focus on different differentiators like model quality or specialized hardware. Here's my takeaway for platform engineers. Start experimenting with cross-region inference now, but do it carefully. Set up proper monitoring, understand your cost implications, and have a rollback plan. This technology is powerful, but it's still early days. The teams that figure out how to leverage it effectively will have a significant competitive advantage in the Southeast Asian market. Before we wrap up, let's catch up on this week's infrastructure news. There's a massive security story breaking. Anthropic just revealed that Chinese AI firms DeepSeek, Moonshot AI, and Minimax used 16 million queries to essentially copy Claude's capabilities through what they're calling industrial-scale model extraction attacks.
16 million queries? That's not just poking around, that's systematic theft. How did they even pull this off without getting caught sooner?
According to the Hacker News, Anthropic has been implementing new safeguards, but this really highlights how vulnerable these models can be to determined actors with enough resources.
And speaking of enterprise challenges, the news stack is reporting that the Pentagon is having serious issues with Claude due to usage restrictions, which they say is actually a problem every enterprise faces when relying on a single AI provider.
Right. The article argues this isn't just a Pentagon problem. It's about the risks of vendor lock-in and the need for model orchestration strategies. Companies need flexibility to switch between different AI models.
On a more positive note, New Relic just released their outlier detection feature to general availability. This is aimed at SRE and DevOps teams who are drowning in alert noise.
The key innovation here is that it compares entities to their peers to identify truly unusual behavior, rather than just hitting static thresholds, should significantly reduce false positives.
Speaking of innovation, there's a fascinating new paper on Archive about detecting hallucinations in LLMs. They're reinterpreting the softmax classifier as an energy-based model, completely training-free.
The paper introduces something called spilled energy metrics to catch when models are making things up. If this works as advertised, it could be a game changer for reliability.
And finally, the Pragmatic Engineer newsletter has an inside look at how Claude code is built.
They're comparing it to Codex and highlighting the cloud-first long-running task architecture.
What's interesting is the author admits they were initially skeptical about the approach, but the technical deep dive changed their perspective on what's possible with these coding assistants.
That wraps up today's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.